Good day, student and market research professional. My name is Dr. Govinda Rai and welcome to my YouTube channel Barefoot Researcher. Today I am going to take you through the application of multidimensional scaling in marketing research. So today's agenda is basically I will be discussing brief about what is multidimensional scaling and how that can be used in a brand positioning. And beside brand positioning, what are the other application of MDS in market research? And we'll be discussing brief about the statistics associated with MDS, and finally we'll be describing the key steps in conducting the MDS, and I'll be explaining with one popular case example, that popular TV brand in India using SPSS. So let us start today's session is with the what is MDS. MDS is basically the class of procedures for representing the perception of preference of respondent spatially by means of visual display. So we mean that we try to have a one brands, and based on certain stimuli, it could be the price and quality, we like to put that brand into that two-dimensional or three-dimension space that we call the spatial maps. So the axis of spatial maps, it could be two-dimensional or three-dimensional, assumed to be denote the psychological assets, like psychological basis that respondent to use to form the perception or preference for the stimuli. For example, when you consider that cold drinks, it could be one axis could be taste, another axis could be price, and it could be flavor for the, if we consider the three dimension, right? So when we consider the brand positioning, like we compare that how one brand is performing in terms of other brands, other brand in the market. Take an example of 5G. So there are 5G mobile phones. So there are various aspects and attributes of a 5G set of mobiles. So we like to see how these mobiles are, positioned with respect to the other brand when you consider the camera. But we also check that what is the consumer ideal brand. So when it comes to the price versus features, what is the ideal brand? In that case, we use the MDS, the multi-dimensional scaling. And multi-dimensional scaling is also popularly used when we measure the consumer perception of firms versus firm's own perception. So we can see the gaps over there. We can also come with a quick commerce, the leading brands Swiggy, Blinkit, Zepto, how they basically consumer or perceive these brands in terms of maybe the pricing and delivery or assortment, and identify the groups of customer based on the homogeneous perception. And we can also do in terms of new product development, look for the gaps in the spatial maps, and we can see that how the product can be placed in the spatial maps with relative to the position of other competing brands. Okay, and the advertising effectiveness also can be measured using the MDS, like before ads and after ads. At the same time, the pricing analytics, we can also when comparing 7 brands, we can also include pricing as a feature, and we can also exclude pricing as a feature. When we exclude the feature, how the brand are positioned. At the same that the make channel decision using the spatial map based on the judgment of compatibility of brands with different retail outlet. The product are sold across online and offline offers. We can measure this. So when it comes to the statistics, very few things are very important to remember. It is called the similarity judgment. So similarity judgments are the rating on the possible pair of brands or stimuli in terms of their similarity using a Likert scale, like a 1 to 5 scale. And preference rating, it's a ordinal. Basically we can tell which is the top order, which is the least preferred. And two important statistics we consider here, we call the stress value. Stress is a lack of fitness factor. Higher value indicates a poor fit. Normally the stress value should be less than 10%, means 0.10. R square is a squared correlation index that indicates the proportion of variance of optimally scaled data. It's a goodness of it. It should be more than 0.6. And spatial maps is a maps basically which comes with the 2 axes on 3 axes, and this axis represent a set of attributes, and sometimes the axis we call the coordinate, that based on the naming of coordinate based on the certain attributes, or maybe the market researcher own perception and judgment. And unfolding, we like to put the both brand and respondents as a point on the map to see how the brands are positioned in that particular spatial maps. Right, these are the few important steps when we consider that multidimensional scaling. First is the formulate problems. Once we have our problem is clear, we need to collect the data. Based on the data nature, we need to select the MDS procedures. We'll be discussing in a short on this. And once we come with the result, we come with the 2 or 3 dimension. You need to give the naming of the dimension, and that is called the leveling. And finally, we assess the reliability and validity of that dimension. So when we consider the problem, we need to the positioning of a brand, or maybe pricing effect, like with price or without price. So that we can do with this. But when we consider the number of stimuli or brands, it could be ranges from 8 to 25. If it's a less number of stimuli or brands, then the dimension should be restricted to 8, but more than 25 number of brands or stimuli, you can have the higher number of dimension. Now, what stimuli or brands you should select, that based on the market research, problem theory and judgment of the researcher. Now, how to collect data? Collection of data can be done in two ways. One is the perception based. The first is the direct. We ask customer to compare brand A with brand B with their own judgment. I'm not giving any kind of reference point over there. But when it comes to that, the derived, I tell you based on certain attributes, then you use to rate, compare one brand with the another brand. And preference is basically the another kind of data where I like to ask my student, can you rank all these 8 brands? 8 is the top preferred and 1 is the least preferred. So when it comes to the direct approach, that's why it's your own judgment, and there are n brands to be evaluated, so evaluation should be n into n minus 1 by 2. And now take an example of the toothpaste. There are 10 toothpaste brands, and you can see the row and column wise. So each brand is compared with the other brand, so there should be 45 comparison. So it is 10 minus 1 divided by 2, it's a 45 comparison. And this is a this is symmetric matrix. You can see it here, the lower half and upper half will be same, and diagonal matrix would be 0, right? And when it's called the derived, again the same thing, but 10 brands I am comparing, toothpaste brand, but I am comparing with respect to whitener teeth or prevent tooth decay or pleasant tasting and all this. So it is whitening tooth yes and whitening tooth no, means it is high to very low rating you can have. The customer will be giving this. And preference data, it's an ordinal in data, so it is based on certain property and common in which the data are obtained preference ranking. So you can tell them when it's a prevent tooth decay, it could be the best is Sensodyne and least is the plus white. So customer will be rating based on that. So there are certain advantage or disadvantage of this. So when it comes to the direct approach, researcher don't have to identify the salient attributes, right? And sometimes it is difficult because since the no attributes are mentioned, so that the researcher have to come with the dimension leveling. So that's another part. Like when it comes to the attribute based, it is easy because to identify respondent with the homogeneous perception, and respondent can be clustered based on attribute rating like cavity protection, maybe white. So based on that particular attribute, you can position the brand, and it will be easier to level the dimension. But on the disadvantage side is basically researcher must have to identify the salient attributes, salient attributes of brand, and that is often a difficult basically, right? So we used both often depend on the attribute. It is always best to use the both approaches as a complementary way. Now when we will be selected MDS procedure, like what then with the non-metric and metric, we call the non-metric MDS when the input data are ordinal, like in terms of order, preference data. But when we consider the metric MDS, basically we call that we take an attribute based, like take an example like teeth whitening. So in terms of take an example of brand, tell me 1 to 5 scale teeth whitening highest level to lowest level. So it's a kind of scale data. So it's the interval or ratio data. But both cases, metric and not metric method produces similar results. Now comes to that how many dimension you need to decide. So it is a prior information like theory and past research may suggest Like it is based on the researcher own judgment, and sometimes it is the interpretability, right? The two dimension are easy to interpret, right? And Elbro criteria is basically stress value. We look at the data that if the stress value is less than 2, we look at the dimension it is indicating. Based on that we can select that, and there are other statistical approaches. Let us example of this plot. You can see the stress versus number of dimension, and at the dimension 2 stress value is zero point 0.1 below 1, so it is we consider the two dimensional solution. 3 and 4 are good, less stress value, but interpretation would be difficult for us to carry forward, right? Now when it comes to that, when we put that without naming dimension, we can see that aim, crest, colgate, aquafresh, these are coming across x dimension and an x positive dimension, right? And you can see the Sensodyne is highly loading on the y dimension, so you can see how they are. But there we are not putting that at what attributes. We now in the next slide we will be putting attributes. Now you see the Sensodyne is good on the sensitivity protection, and fight cavities, maybe Colgate and Aquafresh are very good. Whitening teeth, Pepsodent and close up are very good in that dimension. So this is, we put the attributes, no, as a level dimension. Now how to assess the suitability? Very first thing is the R square of the model. It should be 6 or more, and when it comes to the stress value, it's a badness of it, so it should be less than 10%, means below 0.1, right? So another thing is basically to assess the reliability, sometimes price is important factor. So you see the relative position of brand when you include price of that brand, or maybe you can exclude price and then see the relative positioning, right? So that you can see that with the pricing is a decisive criteria to differentiate brands or not. And sometimes you can delete one or two brand, and then you can check what is the relative position, like in presence and in or in absence of brand, how other brands are performing. So next example I show you here, Sensodyne is there on the left hand side. You see the relative position of Crest, Colgate and Aquafresh. But when I remove the Sensodyne, you see the different set of like Aquafresh comes on the top, right? So you, the relative position gets changed. So that way you can see the in presence and in absence of particular brand, how the other brands are performing. Now when it comes to our example, we consider is a top 8 TV brands in India. So Samsung, Sony, LG, right? And this we placed in a dummy form. Then we ask each customer to put their input. So it is a basically a direct approach. So I am not giving any kind of their any our criteria. They can use their own criteria, right? And customer compares one brand with the other brand. It is an ordinal data, and this is a dissimilarity, right? How one brand is dissimilar to another. So 1 to 8, right? So that's the way you put it. So when it comes to that, SPSS data will be look like this. So now onwards I will be going to SPSS to demonstrate this concept. So let us go to the SPSS. So this is my SPSS data. You can see it here. The all brands name are mentioned across column, and same thing will be across row. And this is a symmetric matrix. The diagonal elements are 0, and the lower half and upper half also the same. Okay, so conduct that our multidimensional scaling. So if we go to the analyze, then go to the scale, then we call the multidimensional scaling scale. So I put on there. Now you can see the set of variable has to be in the variable column. So initially it would be like this. So I put it this side, and then I bring it this, right? This is a variable column. Now the distance data are in distance. We compute with the square symmetric data. So it is already set. Now my data is the options. Option is the individual plots I will be selecting. Stress convergence is 001, so iteration will be 30. So the computation will be completed as soon as the stress convergence reach this level. So I put it continue. Now very important thing is the modeling. So here the level up measurement ordinal data, as I mentioned, right? So pairwise comparison, we compare 1 to 8, right? The 8 brands are there. Now here another important point is basically number of dimension. I look for 1 to 3 dimension. I will be seeking that how this this solution, and so I will get the 3 solution over here, and we will be judging which one will be good. So again, I show you once again. This is the brands. I put it this side. Now distance we measured is square symmetric. We call it the square symmetric. Okay. Then I come to the options. Is basically need to put the individual subject plot. Okay. Gone. Now the model is very important here. The ordinal data I put it over here. Okay. So I put 1 to 3 dimension solution. So you can see it here, the 3 dimension solution. In the 3 dimension solution, it is showing that iteration up to 8 iteration already, that is stress improvement achieved. Very important thing is the stress value. Stress value is 0.50232. So it's a 5%. So less than 10%. RSQ is R square equivalence is 0.96. So very good. Okay. So this is a 3 dimension. These are the coordinates. We can see it here. The coordinates will be used to plot a 3 dimensional plot. 8 brands are there. We'll be looking at that brands. Okay. But important point is basically the stress value and RSQ. Right. Now when we come to the 2 dimension plot, what we can see it here. Basically in the 2 dimensional plot, again after 7 iteration, that stress improvement is less than 0.6. Okay, now stress value is 0.24, but in terms of no, in terms of our RSQ value, it is only 0.58, so it is less than 0.6. And you see the stress value become higher, it is 24%. So this is not an acceptable two dimension solution, right? The coordinates are also here mentioned, right? The coordinate, this coordinate will be used to plot the 2 dimensional plot. Now come with the 1 dimensional plot. Again after 3 iteration, you see the 1 is achieved, but here you can see stress value is 0.43 and RSQ further reduced 0.35, 35%. Okay, so from 96 to 1 dimension it is 0.35. So that is really very bad, right? So we cannot take the 1 dimension solution. So if we go to the 3 dimension, is a 3 dimension solution. But again sometimes it would be difficult to come with this 3 dimension interpretability. But when we come to the 2 dimension solution, it will be easy to interpret. Let us look at this. So this is 2 dimension solution. In this 2 dimension solution, what I see, there is no naming of this dimension, but what we can see it here, OnePlus and Samsung, these two brands are competing and they are high on dimension X, right? At the same time Sony and uh, Onida, these are very high on this. This is a hypothetical example. Okay, so which one is distant? Maybe LG, Panasonic and Xiaomi. Okay, so let us see if we like to give certain name. Maybe the television, it could be something that after sale service, so it could be OnePlus and Samsung. They are very good at this is hypothetically I mentioned over there. Okay, and if we consider the Sony and this is maybe in terms of features, these are the very good too, right? And LG. So with this we can see that how the brand are positioning in this perceptual map. And one thing you can do, we can remove TCL and then we can run the analysis to see the whether the brands are placed similarly or they are placed differently. So that's the way we use multidimensional scaling to see the how the brands are placed along different and axis. And this is a direct method. We compare one brand with the other brands and we come with our suitable this insights. So I think that's all from my side. Thank you, and if you have any question, definitely you can ask me. Thank you and watching the this video, and hope to get to know your views for the or further feedback for the further improvement.